Beneath more than 2 miles of Antarctic ice, there's a lake the size of Lake Ontario that has been completely sealed from the surface of the Earth for at least 15 million years. Scientists drilled through 4 kilometers of glacial ice to reach the frozen layer above it and found DNA from more than 3,500 organisms. Bacteria, fungi, microbes that normally live inside the digestive tracts of fish, in a lake that has had no connection to the ocean or the atmosphere for 15 million years. Subscribe right now, because what scientists have been finding under Antarctica in the last few years is one of the most extraordinary stories in the history of Earth science, and the discoveries are accelerating. The continent of Antarctica is the largest, coldest, most isolated landmass on the surface of the planet. It covers approximately 14 million square kilometers. At its thickest point, the ice sheet above it is 4,776 meters deep, nearly 3 miles of solid ice pressing down on the rock below with a pressure that would crush most structures humans have ever built. The average temperature on the Antarctic plateau is minus 57 degrees Celsius. The interior of the continent receives less precipitation than the Sahara Desert, making it technically the largest desert on Earth despite being covered in ice. For most of human history, Antarctica was completely unknown. Ancient Greek philosophers theorized that a large southern landmass must exist to balance the continents of the north, but nobody reached it. The first confirmed human sighting of the Antarctic continent did not occur until 1820, when separate expeditions from Russia, Great Britain, and the United States spotted the coastline within weeks of each other. The first confirmed landing on the Antarctic mainland happened in 1895. The first people to spend a winter on the continent survived it in 1899. This is not a place that human beings have been engaging with for very long, and the more we look at what is under the ice, the clearer it becomes that we have barely started understanding what is there. The Antarctic Treaty of 1959, signed by 12 nations and now endorsed by 54 countries, established Antarctica as a continent reserved for peace and science. No military bases are permitted, no weapons testing, no nuclear activity of any kind, no mining or resource extraction. No country can enforce territorial claims. It was the first arms control agreement of the Cold War era, and it remains one of the most successful international treaties ever signed. The reason Antarctica is heavily restricted today is not a mystery. It is the most environmentally pristine continent on Earth. It has no indigenous human population. It has no permanent residents. It is the last place on Earth where industrial development has not yet left a permanent mark. The treaty nations decided collectively in 1991, when they added the Protocol on Environmental Protection, to keep it that way indefinitely. Every restriction on what you can do in Antarctica exists to preserve that condition. You can visit. More than 122,000 tourists did so in the 2023-24 season alone. But you cannot take anything out of it, you cannot build anything permanent in it for non-scientific purposes, and you cannot exploit its resources. That is the reason it is off limits to commercial and military activity. The reason it matters to science, and the reason scientists keep going back, is what they keep finding under the ice. There are more than 400 known subglacial lakes beneath the Antarctic ice sheet. 400 bodies of liquid water, sitting in darkness under enormous pressure, completely sealed from the atmosphere for millions of years, kept liquid by geothermal heat rising from the rock below them and by the insulating pressure of the ice above. Scientists identified the first subglacial lake in the 1960s. They confirmed its existence through satellite-based radar altimetry in 1993. By 2022, a team at Sheffield University had cataloged more than 700 subglacial lakes under Antarctica and Greenland combined. These are not small puddles. Lake Vostok, the largest known subglacial lake in Antarctica, is approximately 240 kilometers long and 50 kilometers wide. It is about a kilometer deep at its southern end and holds an estimated 5,400 cubic kilometers of liquid water, making it one of the largest freshwater lakes on Earth by volume. It sits near Russia's Vostok Research Station, roughly 100 kilometers from the South Pole, buried under 4 kilometers of glacial ice. Scientists believe it has been sealed under that ice for somewhere between 15 and 20 million years. The question that makes Lake Vostok extraordinary is not just its size or its age. The question is what has been living in it for those millions of years without sunlight, without atmospheric input, in near freezing water under enormous pressure. Life requires energy. Without sunlight, photosynthesis is not possible. But life has found other ways. Hydrothermal vents on the ocean floor support entire ecosystems that run entirely on chemical energy from the Earth rather than solar energy from the sky. Camellithotrophs, bacteria that extract energy from chemical reactions involving minerals, can survive in complete darkness in conditions that would kill every other organism on Earth. The question is whether Lake Vostok's isolated ecosystem has been doing something similar for 15 million years. Scientists drilled down through the ice and extracted samples of accretion ice, which is lake water that has frozen to the bottom of the overlying glacier as the glacier creeps slowly across the surface of the lake. This accretion ice carries material from the lake itself and preserves it in the ice above. When researchers sequenced the DNA and RNA in those samples, they found genetic traces from more than 3,500 organisms. Bacteria, 2 species of archaea, the single-celled extremophils that represent one of the most ancient forms of life on Earth, fungi, and microbes that are normally found in the digestive tracts of fish intestinal bacteria, in a lake that has been completely cut off from any fish or any fish habitat for at least 15 million years. The presence of those microbes raises questions that science has not yet fully answered about the history of that lake and what it may have once been connected to. Lake Vostok may have been linked to the ocean in the distant past, which would explain how marine-associated organisms ended up in a sealed subglacial environment. Or those organisms evolved independently in an environment that is more similar to a marine ecosystem than anyone expected. Either answer is extraordinary. But Lake Vostok is not the only subglacial lake producing extraordinary results. In 2018, scientists using an ice drill that melts its way through the ice using hot water reached Lake Mercer, a much smaller subglacial lake in West Antarctica, and retrieved the first samples ever taken directly from a previously untouched Antarctic subglacial lake. What they found challenged assumptions about how isolated these environments really are. The sediment at the bottom of Lake Mercer contained organic material, including the remains of crustaceans and other organisms that appeared to have lived in open water, rather than in a sealed subglacial environment. Well, the current interpretation is that Lake Mercer was once exposed to the atmosphere, perhaps when the West Antarctic ice sheet was smaller or absent during warmer periods in Earth's past, and that the organisms living in it then were preserved in the sediment when the ice recovered the lake. That interpretation, if correct, tells us that the West Antarctic ice sheet is not the permanent, stable feature it appears to be. It has retreated before. It has exposed land and water that are now buried under kilometers of ice, and it may retreat again. That connection between Antarctica's past and its future is one of the most urgent scientific questions of the 21st century. The West Antarctic ice sheet contains enough ice that, if it melted entirely, global sea levels would rise by approximately 3.3 meters. 3 meters of sea level rise would permanently inundate coastal cities on every continent. The question is not whether the ice sheet can melt. The geological record shows that it has melted before and that it can happen within geologically short time frames. The question is how quickly it can happen and whether the changes already underway in Antarctica's ice are approaching thresholds beyond which the process accelerates beyond human ability to respond to it. Antarctica has been warming at roughly twice the global average rate over the past few decades. Ice shelves, which are floating extensions of the ice sheet that slow the flow of glaciers into the ocean, have been collapsing. The Larsen B ice shelf, an area of approximately 3,250 square kilometers that had been stable for at least 12,000 years, collapsed in 35 days in 2002. The Conger ice shelf, roughly the size of Rome, collapsed in March 2022 in a matter of days. Scientists studying the Thwaites Glacier, sometimes called the Doomsday Glacier, have found that the rate at which it is losing ice has roughly doubled since the 1990s. Thwaites alone holds enough ice that its complete loss would raise global sea levels by approximately 65 centimeters. And Thwaites is showing signs of internal instability that suggest the warm ocean water that has been melting it from below has reached far deeper into the glacier than anyone knew before a series of underwater surveys in 2022 and 2023. The subglacial geology beneath the ice adds further layers of complexity to an already alarming picture. In East Antarctica, beneath the Wilkes Land region, scientists have identified what appears to be the largest impact crater ever found on Earth. First detected through gravity measurements in 1959 and 1960 by an American expedition. The Wilkes Land gravity anomaly is a circular structure approximately 500 kilometers across, nearly twice the diameter, of the Chicxulub crater that is associated with the mass extinction that killed the non-avian dinosaurs 66 million years ago. The structure shows the gravitational signature of a mascon, a concentration of mass at depth that matches what you would expect to find at a large impact basin. Some researchers have proposed that this impact occurred at the end of the Permian period, approximately 252 million years ago, making it potentially contemporaneous with the largest mass extinction in Earth's history, the Permian Triassic extinction event, in which more than 90% of all species on Earth died out. If the Wilkes Land impact happened at or around the same time as the Permian Triassic extinction, it might have been a contributing factor to that catastrophe. The structure cannot be directly accessed for study because it sits under more than 2 kilometers of ice. It can only be examined through gravity mapping, radar surveys, and magnetic measurements from above the ice. The evidence for an impact origin is compelling but not yet definitive. The Wilkes Land anomaly has also been proposed as a volcanic structure, a tectonic feature, or an ancient sedimentary basin. Resolving its origin will require either a significant advance in remote sensing technology or an access method that does not yet exist. The continent is also actively volcanic in ways that most people do not realize. Mount Erebus on Ross Island is the southernmost active volcano on Earth and has been erupting continuously for decades. But the volcanic activity in Antarctica is not limited to the surface. Surveys using ice-penetrating radar have identified what appear to be volcanic features beneath the West Antarctic ice sheet. Heat sources that are warming the ice from below, accelerating the melting of the base of the ice sheet in ways that add to the instability driven by warming ocean water from above. In 2017, a team at the University of Edinburgh identified 91 previously unknown volcanoes beneath the West Antarctic ice sheet through radar surveys, bringing the total number of known volcanic features in the region to 138. These are not all active volcanoes. Most are ancient features, but some show evidence of being potentially active, and any future eruption beneath the ice sheet would have dramatic consequences for the stability of the surrounding ice. A volcanic heat, even without a surface eruption, can create meltwater at the base of the ice sheet, lubricating the interface between the ice and the bedrock below and allowing glaciers to flow faster toward the ocean. The bedrock beneath the Antarctic ice is not the uniform flat surface that early scientists imagined. It is a landscape of mountains, valleys, canyon systems, and basins, as complex as anything on the surface of the continents. The Gumberts of subglacial mountains buried under East Antarctica are comparable in scale to the Alps, and were completely unknown to science until surveys revealed their existence in the 20th century. The Aurora subglacial basin in East Antarctica is one of the deepest bedrock depressions on Earth, sitting 3,000 meters below sea level, filled with ice above it. If the ice sheet covering the Aurora basin were to melt, the resulting void would fill with ocean water, and the marine ice sheet overlying it would become fundamentally unstable, because marine ice sheets, those that sit on bedrock below sea level surrounded by ocean, are subject to a runaway dynamic called marine ice sheet instability that does not apply to ice sheets on land above sea level. The connection between Antarctica and the broader story of 20th century geopolitics is itself genuinely fascinating and completely documented. The Cold War came to Antarctica before the Antarctic Treaty resolved it. In 1946 and 1947, the United States Navy conducted Operation High Jump, the largest single Antarctic expedition ever mounted to that point. 13 ships, 23 aircraft, more than 4,700 military personnel. The stated mission was to establish the McMurdo Research Station, train personnel for cold weather operations, and test military equipment in polar conditions. The unstated competitive pressure was the Soviet Union's growing interest in the continent and the territorial claims of multiple allied and rival nations that had been staking out Antarctic territory since the early 20th century. 7 countries held overlapping claims to Antarctic territory. Britain, Argentina, and Chile each claimed the same section of the Antarctic Peninsula, and their claims overlapped on a map in a way that had already led to armed confrontation. Argentine military forces had fired on British troops in the Antarctic in 1948. The United States had no territorial claim of its own, which gave it a particular strategic interest in ensuring that no single power gained dominance over a continent that sits at the bottom of the world and controls access to the waters surrounding it. The Antarctic Treaty of 1959 was not an act of altruism. It was a diplomatic solution to a problem that was becoming genuinely dangerous. 7 nations had incompatible territorial claims. The Soviet Union was moving into the region. The United States, under President Eisenhower, decided that a treaty that froze all claims in place, banned military activity, and opened the continent to free scientific investigation was more strategically advantageous than any alternative outcome. It was also genuinely good policy. The scientific cooperation that the treaty enabled during the International Geophysical Year of 1957 and 1958, when 12 nations ran research stations on the continent simultaneously and shared their data openly, produced more knowledge about Antarctica in 2 years than the previous century of exploration had generated. That cooperation became the model for the treaty itself. Now here is where the real present-day urgency of Antarctica connects to everything that has been discovered beneath its ice. The Thwaites Glacier sits on the western edge of the West Antarctic ice sheet, draining an area of ice roughly the size of Florida into the Amundsen Sea. Scientists have been calling it the Doomsday Glacier, not for dramatic effect, but because its potential contribution to sea level rise and its position in the ice sheet make it the single most important glacier on Earth for understanding how quickly the West Antarctic ice sheet could destabilize. The ice shelf that extends from Thwaites into the ocean, floating on the water and acting as a buttress that slows the flow of the glacier behind it, has been showing signs of critical instability. In 2023, surveys using underwater robots and autonomous vehicles that penetrated beneath the floating ice for the first time revealed that the warm circumpolar deep water, which has been melting the underside of the Thwaites ice shelf from below, has carved a series of underwater cavities into the base of the shelf that are far larger and extend much further inland than previous models predicted. These cavities reduce the contact area between the ice shelf and the seafloor ridges that provide it with additional stability. Less contact means less friction. Less friction means faster flow. Faster flow means more ice entering the ocean per year, which means more sea level rise. The rate at which Thwaites is losing ice has approximately doubled since the 1990s. Current estimates project that complete loss of the Thwaites ice shelf could occur within the next decade, after which the glacier behind it would flow into the ocean significantly faster. If Thwaites itself were to fully destabilize and flow into the ocean over subsequent centuries, the sea level contribution would be approximately 65 centimeters. But Thwaites sits at the edge of the larger West Antarctic ice sheet and acts as a kind of plug or barrier holding back the glaciers behind it. If Thwaites goes, the ice sheets behind it become more exposed to the same warm ocean water that has been destabilizing Thwaites itself. The worst-case scenario for complete West Antarctic ice sheet loss is sea level rise of 3.3 meters above current levels. The timeline for that scenario spans centuries to millennia, depending on the pace of warming, but the direction is not in question. What is happening in Antarctica right now is real, it is measurable, and it is the reason that the 54 nations that have signed the Antarctic Treaty continue to treat that continent as one of the most important places on Earth to monitor, study, and protect from any activity that would compromise the scientific work being done there. What is also happening in Antarctica that rarely makes headlines is a revolution in what scientists are able to see under the ice. The British Antarctic Survey and its international partners have been developing increasingly sophisticated ice-penetrating radar systems that can produce images of the bedrock thousands of meters below the surface with a resolution that was impossible even a decade ago. The Bed Machine Antarctica project, which compiled data from multiple surveys, produced the most detailed map ever made of the bedrock beneath the Antarctic ice sheet in 2019, and updated versions have been refined since. What that map revealed was a landscape of extraordinary geological complexity. Deep canyons connecting the ocean to the interior of the ice sheet, below sea level, that provide pathways for warm ocean water to infiltrate further inland than previously modeled. Mountain ranges comparable in height to the Alps, sitting entirely beneath the ice with no surface expression whatsoever. Basins that sit so far below sea level that they would fill with seawater if the ice above them melted, creating the conditions for marine ice sheet instability. The combination of what the bed map reveals about the terrain and what oceanographic surveys reveal about the warm water flowing under the ice sheets has given scientists a much clearer picture of exactly which parts of Antarctica are most vulnerable to accelerating loss and why. That knowledge is urgent. The decisions being made now about carbon emissions and global temperature targets are decisions whose consequences will play out on Antarctic ice over timescales of decades to centuries. Every fraction of a degree of warming that is avoided translates into a delay in the processes that are already underway on the ice sheet. The science being done in Antarctica, protected by the treaty that keeps the continent off limits to exploitation, is the science that tells humanity how much time it has to make those decisions. Not ancient human structures under the ice, not suppressed civilizations, not government cover-ups. But before the final picture is drawn, there is one more discovery that sits at the intersection of everything, and that deserves to be stated clearly. In 2023, scientists drilling into bedrock beneath the Antarctic ice at a site called Skytrain Ice Rise in West Antarctica recovered sediment cores that contained remnants of ancient plant life, pollen, and plant fragments preserved in the rock below the current ice sheet. When those organic materials were dated, they revealed that at some point between 8,000 and 10,000 years ago, when much of the northern hemisphere was experiencing the warmth of the early Holocene after the last ice age, West Antarctica experienced a period of warming so significant that at least parts of it were free of ice entirely, or nearly so. That finding matters enormously for understanding how sensitive the West Antarctic ice sheet is to temperature changes. The warming that produced that ice-free period was not dramatically larger than the warming currently projected for the coming centuries under realistic emission scenarios, which means that the ice sheet currently sitting over West Antarctica, the one containing enough water to raise global sea levels by 3.3 meters, has been absent within the history of human civilization. It melted before. It came back. It is not permanent. The conditions currently driving the melting are moving in exactly the same direction as the conditions that produced the last absence. The real discoveries are genuinely more astonishing than any invented narrative. A lake the size of Lake Ontario, sealed for 15 million years with thousands of unique life forms inside it. The possible largest impact crater on Earth, buried under kilometers of ice. More than 400 bodies of liquid water existing in complete darkness under the ice sheet. 91 previously unknown volcanic features beneath the West Antarctic ice sheet. bedrock landscapes as dramatic as the Alps that no human eye has ever seen directly. A glacier the size of Florida losing ice twice as fast as it was 30 years ago. The real discoveries being made in Antarctica right now by scientists from dozens of countries operating under the framework of the Antarctic Treaty are extraordinary enough that they do not require any embellishment. The continent has been off limits to exploitation not because something is being hidden there. It has been off limits because it is the most important scientific laboratory on Earth, and because what happens to that ice in the coming decades will determine where the coastlines of every continent on Earth are drawn for the next several thousand years. 400 subglacial lakes, 91 previously unknown volcanoes under the ice. The possible largest impact crater on Earth buried under kilometers of ice in Wilkes Land. A lake sealed for 15 million years with DNA from 3,500 organisms. Mountains as large as the Alps that exist entirely under the ice and cannot be seen by any human eye. A glacier the size of Florida that is losing ice at twice the rate it was 30 years ago. And a bedrock record proving that the ice sheet over West Antarctica melted and disappeared within human history, and that conditions moving in the same direction as those that caused the last melting are already underway today. That is the discovery that made Antarctica off limits. That is the discovery that keeps 54 nations cooperating under a treaty that has survived Cold War tensions, territorial disputes, and decades of geopolitical competition to remain one of the most successful international agreements ever signed. The secret of Antarctica is not what is hidden under the ice. The secret of Antarctica is what the ice itself is telling us about the planet we live on and the decisions we are making about its future. Subscribe right now so you never miss what Antarctica's science reveals next. Share this with anyone who thinks the real story needs to be invented to be interesting. And comment below with which of these discoveries surprises you the most, because every one of them was sitting under the ice long before anyone went looking for it.